I didn't want to leave you all without a video today. Today was a little bit of a different day. It's Friday. I wasn't feeling very well in the morning, so I'm taking a little bit longer to make this video. I just came back from the movie theaters. I watched a movie called Barbarian, and it was phenomenal. So if you're into seeing that, if you're into horror movies, highly recommend going to see it. It was a lot of fun. I'm not even doing this live because it's actually right after the movie. And frankly, I'm a little bit tired, but since I've been keeping up a pretty good streak of doing these videos, I don't want to miss out on, missing today. So without further ado, let's go ahead and get started. I'm going to probably make this video short, probably 30 minutes or less, mostly just to make sure that I get a video out there like I've already said. We're going to start from algorithms, acceptance like we always do. We're going to flag the easy questions down. Cool thing is now we're on page 4, so making very, very good progress. And let's see where we can goat. Let's see where we can goat. Let's see what we can get to. So short is completing word. I think maybe we slowly revisited this. Did we do this one yesterday? No. But it has a really bad like to dislike ratio, so I probably won't even consider it. Largest substring between two equal characters. We tried that one yesterday, so let's try this one. Minimum distance to the target element. Okay, so given an integer array nums, 0 indexed, and 2 integers target and start, find an index I such that nums of I equals target, and the absolute value of I minus start is minimized. Note that absolute value of x is the absolute value of x. Okay, that seems kind of redundant to say, but return absolute value of I minus start. It is guaranteed that target exists in nums. So 1, 2, 3, 4, 5, the target is 5, and we're starting at 3. So nums of 4 equals 5 is the only value equal to target. So the answer is abs 4 minus 3, 1. So given integer array nums and 2 integers target and start, find an index I such that nums of I is equal to target and abs of I minus start is minimized. So the shortest distance between target and start. So target is 5, start is 3. And we're looking for 4 and 3. So target is 5. Nums of 4 equals 5 is the only value equal to target. So the answer is absolute value of 4 minus 3. Now, let me see. When they say nums of 4, okay, and start is equal to 3. Should that be? This is a little bit weird. Oh, nums of 4 equals 5. Oh, so it's I minus start, which is 3. Okay, target is 1. Every value of nums is 1, but nums of 0 minimizes abs of 1 minus start, which is abs of 0 minus 0. So if we were to, let me think about if we can like sort this or get the minimum distance. There's not a lot of examples here, so we might have to come up with our own example. Let's look at our constraints. There's nothing in constraints that is telling me that we can use a particular data structure. And what I mean by that is sometimes we see like maybe we're only going to be using lowercase letters, so we decide to use a fixed size array, or maybe our upper bound is only bound to 100 different numbers, so we might just also use a fixed size array. Nothing like that here. So the way that I see it is we have our target, right? We have our target, which is 5. So the first thing we should do is look for 5. We should look for every instance of 5, and we should look for start. And I'm guessing that start target is in nums. I'm guessing that these can be duplicated. They don't necessarily have to be. Target is in nums and target is 5. Okay. Target is in nums, but start might not be in nums. I feel like we can have multiple values though. Like, is there a possibility for us to have, let's see, if I come over to the console and use example test cases, let me actually do this. Or how is that written out? 5 and 3. If I do something like 4, 3, 5, 4, 3, 5. Well, the answer is still 1 here. Okay. Now if we modify it to be some, well, we just removed what we had previously. If I instead do I minus 4 is 5, and that's 4 minus 3, which is 1. And what if I put let's say there's another one that's like 3 and 5. Well, that would still be, would that, I guess that would still be 1, no? That would still be 1. So maybe I don't even want to make it 4. What if we did something like, we had 5 here and this was like a 7? Trying to see if this would work. So that's 3 because abs of I is 0 and start is 3. 0 minus 3. Okay. So I think the question's like, we have multiple, so we're gonna have multiple indices of target, but only some of them. Maybe we should just get every single place. Nums4 equals 5 is the only value equal to target. What if we were to find every value of, I think what we can do is, okay, we get every value of start, and I guess every value of target. We get every value of target, because I'm guessing there can be multiple of each. And once we have each, based on those two arrays of indices, we can figure out which ones are the closest to each other. That's sort of what I'm thinking of doing. Target exists in nums, but start might not. Two integers starting to start finding in its eyes such that nums of I equals target is minimized. Right? Because we could have multiple targets, but no starts. This reminds me a lot of this other question we did before that I can't remember the name of right now. But it was something similar where we had to find like the closest character to the current position. This almost reminds me of that. Let's see. Given an integer array nums and two integers target and start, find an index I such that nums of I equals target. And how would that help me? Like if I had all the indices of start and target, I guess as long, I mean, well, let's figure that out. Let's actually go on Excalidraw or something. Or we can just like write it out. Like here we have, let's say we had, I don't know, target at like 1, 3, and 5. And then we had start at 4, 5, and 6. So target is I minus start. Well, I guess it doesn't really matter the value. It doesn't really matter the position that start is in, right? It only matters the position of target. Because target of 5 is 4, but start is always 3. I is the thing that's going to change. Start will always be the same. So I don't think we need to worry about start. I think we just need to worry about target. Yeah, wait a second. I think what we can do is we can say let min equals infinity for const n of nums if n, oh, we need to do a for let I equals 0, I less than nums dot length, I plus plus. Here we can say if nums of I is equal to target, and maybe min, should min be 0? No, maybe min shouldn't be 0, because if there aren't any, let's see, nums of I, nums.length, that's 10 times 10 is 100, 10,000. Let's make this 10,001. I'm doing this for a very specific reason. If nums of I is equal to target, right, because we know that it says that target is guaranteed that target exists in nums. So anytime we find a target value, we just subtract -3 and calculate that distance, and we just return the minimum of that distance. In the end, if we never found, like all of these are equal to target, 1 minus 0, every value of nums is 1, but nums of 0 minimizes I minus start. Start is 0, 1 minus 0. Actually, do we even need to? Okay, let's try something else. If nums of I is equal to target, then min equals math.min of min, or the math.abs of I minus start. Return min. Perhaps that's just it. Let's run it for all our different test cases. 1, 0, and 0, 1, 0, 0. Let's submit this. Okay. It's funny because when I saw this question, for some reason in my head, I don't know, I think when I was like reading through it, it seemed a little bit more difficult, but as I started just working it out in my head, it made more sense. I feel like there's a lot here that can confuse you, but really, I think the thing that's important is that the target will exist in nums. So the target is 5. So anytime you find the target, and we already know it's going to be in there at least once. So anytime we find target, we just subtract it minus start, and we continue taking the minimum value of that, and then we end up with whatever our answer is, and we have min. So as far as time complexity goes, it's a linear time complex algorithm, if that's how you would say it. And for space complexity, it's constant, right? Very curious to see what discussions might say here. Is it not? As an optimal optimization, we exit early if res cannot be improved anymore. Okay, and res is greater than abs of start minus I. Another optimization is to initiate the search from the start position. It is potentially faster when the target is close to the start. If res cannot be improved anymore. So res equals absolute value of start minus I. It's also read that they're not taking the minimum here. For int I equals 0, I see what it's saying. As soon as you find, like you always, this is sort of taking care of the minimum value. Anytime that you find, so you find the first time that nums of I equals to target, you calculate some value. The next time you come around, you do the same thing again. And as soon as this is greater, right? Or only if this is greater do you keep going. Else, if what you already have in res is less, you can just break early. That's very clever. That's very clever. I like that. Yeah, that makes a lot of sense, actually. I think that's good. Cool. So solid question. Definitely like it. Got to update my website. If you guys haven't seen my website in a while, I haven't updated my website in a while, but that's okay because there's a ton of questions to do there yourself anyway. Yeah, I need to add a couple more. We're at 122 right now. Probably can get like 8 more from all the different questions we've done recently. All right, so rank, transform, and array. Let's see this next one here. All right, another good question. Nice, very good question, actually. Given an array of integers r, replace each element with its rank. The rank represents how large the element is. The rank has the following rules. Rank is an integer starting from 1. The larger the element, the larger the rank. If 2 elements are equal, their rank must be the same. Rank should be as small as possible. Okay, so given an array of integers, replace each element with its rank. So 40 is the largest element, 10 is the smallest, 20 is, okay. They're all the same. So we just want to put it in place. Now, obviously, the thing that we can do that makes this very simple is to sort it. Well, sort of. Yeah, we can sort it and then map each one. If we sort it from least to greatest, then this one would map to, yeah, I think that's really the move here. However, what we could do, yeah, the constraints makes it a little bit difficult because this, first of all, the input array is going to be fairly large, right? That's going to be what, 100,000, because 10 times 10, That's 100 times 10 is 1,000 times 10 is 10,000. Yeah, so times 10 is 100,000. That's a lot. And each individual number in these is going to be very large. So what I'm thinking about doing is if we have, let's say we have 40, 10, right? If we sort this, I can sort this and give it its own sort of index, right? And once I give it its own index, I can say 10 belongs to the index plus 1, and that will give 10 the rank of 1, right? So I can go through here and say 10 is equal to 1, 20 is equal to 2, 30 is equal to 3, 40 is equal to 4, so on and so forth. I can store the index of each one of these, and then at the end when I'm going through like my input, I search up the relevant number and I just add 1 to its index. That's what I'm thinking about doing. I mean, that seems like the easiest way for me to do this. The larger the element, the larger the rank. If two elements are equal, their rank must be the same. So that's a very important note to take in right there. If we have equal numbers, they'll be next to each other. I think what we can do is we can, let's see, we go through the ranks and we only update the index when the values change. So let's go ahead and do that. Let's do const sorted array equals r.sort. Let's do a minus b. And then from here, we can also do const indices. That's going to equal an object literal. And I can say for let I equals 0, I less than sorted r dot length I plus plus. We can say indices at sorted r of I is equal to I. Now we can go through, let's see how we do this. If we have numbers that are the same, 5, 3, 4, 2, 8, 6, 7, 3, 1, 2, 3, 4, 5, 6, 7, 8. None of the numbers here are repeated, not that I can see, right? 100, 100, 100. Yeah, I think we always just take the index. Oh, I see though. We don't take 100, 100, 100. Okay, so I think when we sort it, we only take the index the first time. So here we should say if indices of sorted I, right? If this is undefined, then we'll give it an index. Because in this case, we'll see a 100, we'll set it to index 0. The next time we see it, indices will already have a value, so we don't set it again. That way we're not always increasing the rank of the output. We're only setting it equal to whatever the first rank was after we sorted it. Hopefully that makes sense. So now if we go through here, we can actually say return r.map, where we take each value, right? So let's say value here, and we're going to return indices of value plus 1. So let's see if this works. Nan. I love that. Okay, let's see. r.map of value. We have 40, 10, 20, 30. Sorted array equals a copy of array. This should be a copy. Sorted a b, a minus b. Okay, that looks fine. Const indices. For let I equals 0, I less than sorted r dot length. If indices of sorted r at I equals undefined, then indices of sorted r at I equals I. We only set that the first time we see it in our array, and then we return array.map, where we take each value and we return indices of value, so the ith position plus 1. Let's try this out. 4, 1, 2, 3. So I think it was just because of this we weren't doing the spreading operation correctly. Let's do it for the other test cases. 1, 1, 1. All right, I think, do we have a off by 1 error here? What could have happened was input. Okay, let's see. Let me sort this myself in the dev tools, and let's see it. Let's make sure we're looking at this the right way. So dot sort a BA minus B, 5, 9, 12. Okay, so we have 12, 12. So the first time we see 12, so 5 should be at 0. Now the rank, let me see. Okay, any 5 should be 0. So yes, that should be 1. Now our 2s should be the 9s, 0, 1, 2. So we did end up here with a 5, but now my output was a 6 here. So why is that? When I sorted this, for let I equals 0, I less than sorted array dot length, so it's this. If indices of sorted array at I, so if indices at 5 is undefined, which it is to begin with, then indices of sorted I equals I. I have to sneeze, apologies. May have been the first time I ever sneezed on a video, but hey, now you guys know how I sound when I sneeze. So if indices of sorted I is undefined, which it is, we say indices of 5 is equal to 0. That means that when I come to here, let me see, my 37, should that be a 6? 0, 1, 2, 3, 4, 5. 0, 1, 2. Only if it's undefined. So it's almost like we came back here. If indices of sorted I is equal to undefined, but we've already set it once and we set it to 2. Indices of sorted I, if it's equal to undefined, set it to I. Else, if it's not, just don't do anything with it, right? We shouldn't have done anything for that second one. Is it something that I'm perhaps, does it not like the no braces? It seems like it should be right to me. 1, 1, 1, 6, 3, 5. So we're only off by 1. Let's see. Console.log 653. So we take that last one again. For let I equals 0, indices sorted I equal to undefined. So 5 should be the first one, which it is at the end. And check this out, like it works for 5. What should be the second thing? 9 should be 1. Right, so where's the 9? The 9 is at the 0, 1, 2, 3 position. So it's already messing up for 9. Or no, it's not. Yeah, 9 is 1, so it's 2. Okay. 12 is 2, so it should be 3. Where's our 12? 12 is here. So it should be 3. And 12 is here, so it should be 3. Okay. So far, so good. 28. Oh, I see. It's because the I, right? We need to... I can't set it equal to I. I should instead have... Yeah, I think we need to set a different variable here called position. And here we can set it equal to position plus plus. Because the I is going to keep increasing, but the position should only increase when I actually set it. There you go. That looks better. So let's go ahead and run this. Let's submit this. 81.93. Very nice. Let me submit it again just to go ahead and see if that time complexity stays about the same. $32.26. All right. Let me run it one more time. All right, 31.29. Let's check out the discussion section. Can we do it without sorting? Hash map, okay. We did use a hash map. Set sorted plus dictionary. Let's see, hash map. Copy R into A and sort it. Iterate sorted array A and record the rank for each element into hash map ramp. Iterate R again and assign rank Ri to AI, return the final result, O of n log n, and space of n. Exactly what we came up with. So very happy. I'm trying to make more of an effort to always look at the discussion sections when we're done, because that's where we know that we can potentially learn the most. So pretty much exactly what we did. We even did create a copy of the original array. We also sorted it. We created our hash map. Yep, put if absent is pretty much the same thing that we did where we're checking for undefined and only increasing the position. All right, now rank.size, integer rank, hash map integer rank. Oh, they're basing it on the size of the actual object itself. I'm not sure if that's a constant time operation in JavaScript to get like the amount of keys in the object. I think it's better that we actually use position. That might actually save us some more time. And then they just get the rank just like we did. So I think that's good. Nice. Very happy with that one. See if we can do like one more. I think that would give us just about that half an hour mark. Great. Another high quality question. You're given a string num representing a large integer. An integer is good if it meets the following integers. Conditions. It is a substring of num with length 3. It consists of only one digit. Return the maximum good integer as a string or an empty string if no string integer exists. There are two distinct good integers, 777 and 333. 777 is the largest, so we return 3. I think what I would like to do, we can go through our string. We can always check to see if any three numbers match. Yeah, I think this could be like there may be leading zeros in num or a good integer. This seems to me like it could potentially be, this could be a sliding window problem. I think what we do is like in this case, what can we do? Start and end. So here we have start and end. We can increase end. If these are not the same, we increase start. We keep going. They're the same. Cool. They're the same. Cool. And we keep sort of like, how do I say this? We continue keeping track of the length. Anytime it's 3, then we know we're at a place where these are all the same. So we can like parse the slice of that string and then set that equal to max. And now we'll keep going. This is 4, so we reduce this, and they're not the same. But maybe instead of a sliding window, we can do something easier. I don't think we need a sliding window. I think we just need to see whenever we have 3 that are next to each other. But then, yeah, in this case, 3, 3, 3, 9. Does it matter if we have like 4 3s? I don't think I need to check these 3s and these 3s. I think anytime I have some numbers next to each other. Yeah, I'm thinking about this. We can keep track of like a previous and a current. If the current is not equal to the previous, then we reset it. If it is, we increase it. Anytime it's 3, then we can parse the previous digits. But that also seems a little bit weird. 0 is the only good integers. They may be leading zeros in num or a good integer. Substring of num with length 3, it consists of only one unique digit. Return the maximum good integer as a string or an empty string if no such integer exists. Okay, so let's say we have our previous and our current. And let's say that the previous in the beginning is just equal to null. So if current is not equal to previous, then we reset current to equal previous. Cool. and we keep a count of like 1. All right, so we go to current. They're not the same, so we make them the same. We set the count equal to 1. They're the same, so it's 2. They're the same, so we increase the count to 3. As soon as they're 3, we can slice this. So what I'm thinking about doing is I can say let current equal num at 0, let previous equals null, for let I equals 0, I less than num dot length I plus plus. We can say if current is not equal to previous. Let's also say let length equals to 1. Then here we reset length equals to 1, previous equals current, else length plus 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 or equals 1. If length is equal to 3, then what do we say here? I guess we'll have to have let good integer equals, let's see, for the string we'll set it equal to empty, and then we'll say the current max is equal to negative infinity. Here we can say if length is equal to 3, let's see, I guess we only want to, I guess we should parse, let me think about this. I think we need to first parse the string wherever we're currently at, which is going to be, let's see, const sliced string is going to equal num dot slice. We're going to start at, like if I'm at 7, I'm going to start 1, 2 before my current I. So I'll start I minus 2, and I'll go up to 1, 2, 3. I'll go up to I plus 3. I know it looks a little bit strange, but here I can say if parse int of sliced string of 10 is greater than good integer dot max, then we'll say good integer dot max equals parse int of sliced string 10 and good integer dot str equals sliced string. And then I think at the end we can just return good integer dot str. Would that work? I mean, I'm kind of just like going off the cuff here. Let's see. Okay, I put this up here. It doesn't like this, obviously. Probably need to also reset expected 6771. Okay, that's fine. Let's see, go through this, right? We have current. We also have previous, and length equals 1. So if current not equal to previous, which is not, length equals 1, and previous equals current. So now we keep going. I equals 0. So current I need to keep increasing. I think that's already where I kind of messed up there. Here, I don't even think I don't need current here. I can just say if like my current will be num of I, right? So let's start again. If num of I not equal to previous, length equals 1, previous equals nums at I, num of I. Okay, we continue. All right, and now we're at the next one. If num of I not equal to previous, which is not, length equals 1, previous equals num of I. All right, we come over here, they're the same, so length plus or equals 1. Here, they're the same, so length plus or equals 1, they're 3. Now, since length is equal to 3, the sliced string, we want to take these 7s, right? So we want to go from I minus 2. I is where current is, so I minus 2 gives us this first 7. And we want to go from I minus 2 to I plus 3. 1, 2, 3, because it never includes that last one. So I'll give us the 7 right here. And then we'll say if the integer that we just got from the slice string is greater than we currently have in max, then we'll set the max to that, and then we'll set the new string to slice string. And then after this, we can just continue onwards, and it should continue shrinking that window down. Let's run this again and see what we get. 7713. So what happened here? Okay. Let me just get this piece here. So there was a point where we were at previous, and we were also at current. The next time current comes up, num of I is not equal to previous. So previous equals num of I. Length equals 1. Come over here, we increase this one. So I'm already curious why. It might be with this length thing down here. If length equals 3, 777. Let's see if we can figure it out. Console.log of sliced string. Seven 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 one three. If length, length is literally not equal to 3 here. Length equals 1. Length plus or equals 1. That's bizarre. Previous equals null. And we have I, which is equal to 0. Num of I is not equal to previous, which it's not. Length is going to be equal to 1. And previous equals num of I. Okay. Length is not equal to 3, so we don't do anything. We come over here. If num of I 7. No, yeah, that's fine. If num of I previous equals num I, not equal to previous, which is not. Length equals 1, previous equals num of I. So it's here. Okay. So now we increase I. If num of I is not equal to previous, that's not the case. Length plus or equals 1, which is 2. If length equals 3, we don't do anything. Come over here. If num of I is not equal to previous, that's fine. We get to the 3 here. Cool. So sliced string, which somehow is 77713. So it's probably something here, right? Num.slice I minus 2. Let me look up, I guess we need to look up slice, right? MDN slice. Start and end. Zero base index at which to start extraction. Okay. I see why. I minus 2 plus 3. No, we just need to go to I plus 1. That's why. Let's try this out. Because this is the end. Right? I was taking I plus 3 to be like I minus 2 we go back to, and then from the end is starting from where we started, but really I is always going to be the same digit, so it's going to be I minus 2 and then I plus 1. Seven seven zero 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 zero, an empty string. All right, that looks good to me. Let's remove that console log and let's go ahead and submit this. And if it doesn't, oh, that's awesome. I was going to say, oh, if it doesn't work, we can just figure it out in a weekly roundup. I think this is a pretty interesting question. I like it. It's very, it's interesting for sure. Do I feel like I'm not a huge fan of doing the slicing and the parsing right here in the middle. I can't help but think that there's a better way of doing this. The only thing is this is a string. I'm going to have to parse it to know the number and to know if it's bigger. And I'm going to need to take a slice to know what to compare. So let's check out the discussions and see what they got to say. Compare with two previous. Oh, but this is not helpful. Okay, so intuition behind O of 1 space. Get maximum by checking only a single digit. And the question is given that a number is unique if all the digits are the same. So instead of comparing substrings, we can simply compare single digit, because if 7 is less than 8, and 777 is less than 8. So I plus 2 is less than num.size. If num of I equals num I plus 1 and num of I equals num I plus 2, then the max is the whatever the current answer is, or the num of I minus 0. I see what they're saying. They're not really storing anything. They're just looking 2 ahead. They're comparing the next 2 strings with each other, the next 2 characters with each other, and only comparing a single digit, since we know they're all 3 going to be the same. This is simple solution using brute force approach, O of 3 space. If num of I equals num I and num of I equals num I plus 1, string temp, and you compare that. Okay, yeah, I think that's also a better way of doing it too. You can just take the middle number, compare it to its left and right, and you can make a string based on that. Simple and short, full explanation. Taking a car with 0 initially, that will start our answer. Iterating from the third element and start comparing it with the first and second element. Found a triplet. After all the iteration, if our answer is empty, then return an empty string. Also return the max character in the form of a string. And what did we do again? Yeah, we were comparing the lengths. So yeah, we could shorten this a little bit. I think we'll still want good integer, but I guess we don't need length and previous. Here we can start at 1, and we can go from num.length minus 1. And then really what we want to do is, I think this is the most important piece here. What I want to say here is if num of I minus 1 is equal to num of I, and num of I plus 1 is equal to num of I, from here we can get our sliced string. Here we'll go I minus 1 to I plus 2. That sounds about right. Yep, I plus 2. And that should still give us the right answer. 777. A little bit more of a concise way of doing it. Yeah, we still get the right thing. Yeah, anytime there's like a fixed amount of numbers or a fixed amount of digits we have to consider, it might be better to just, like in this case, we had a triplet, so we only considered the middle one and looked left and right, instead of doing something when we find the first character and look 2 indices to the right. We just look at the middle one and then do something based on that. And we can sort of shorten our iteration here. So in this case, the time complexity here will be, let's see, every time we're doing a slice, it does take time, but this is always going to be constant in the sense that the slice will always be 3. So it's like n times some constant time. So I think this is still O of n, and the space complexity here, I'm not sure. I think slice does return a new string, so that might take some space, but it's also constant. So I'm good with saying that it's linear time complexity and constant space complexity. And I think, what else did we do here? O of 3 space, yeah, O of 3, which is our constant time. Rather, constant space. Okay, sweet. So I'm pretty happy with this. I'm very happy with all the questions we did today. We went over 3 solid questions. I think it's a great way for us to, do today's stream. I know it was a little bit weird. I didn't do a live stream today, but I'm happy that I was able to at least come around, record something for you all. I think that we got a solid amount of questions in, so definitely looking forward to having you all around. I realized that I was on the wrong session, so I'm going to have to copy these answers over to the other session. That way we keep our streak going up. I'm using this session for my other Explore card videos that I've been doing on my channel, so make sure to check those out if you like that. But again, thank you all so much for joining. We'll be on tomorrow for another normal LeetCode stream. Hoping to see you all then. Hope you all have a great night and happy coding. Later.